Hey, welcome to the channel. We are continuing our series on Go language, and this is part 2. Let's talk about pointers. For that, I would first need a simple variable. This is how I'm gonna declare it, define it at the same time. No need to add what the type is. I'm gonna name it myvar. And then how am I going to declare the pointer? I'm just going to use the same way, but what I'm gonna do is I'm gonna say ampersand myvar. This is how we use a pointer to point to a variable. I'm gonna say println p. That gives me an address. This is the address where 100 is stored, and p is the pointer to that. But what will happen when I do star p? Let's try running it. 100. Similarly, using star p, I'm also going to change the value. If I still do p, I would continue getting to the address that was pointing towards it. That's the pointers in Golang, much like other languages. Let's talk about structs next. How do we define them here? The keyword that we are gonna use is type, and then I can say the name vertex, and then I can write struct. Similarly, how we define a particular variable, we do var x int. Similarly here, type, name, and the struct. And how do we define it? I can write here tab x int, and then I can say y int, and that way I'll have a struct. I can print vertex, and then within curly brackets I can say 1 comma 2. Let's see, I got 1 comma 2. So let's say I'll have b, and how I'm gonna do is I'm gonna say this is basically my vertex, and then I'll do v dot x. So I got 1. So v dot x is the way that I can access the variables within a particular struct. I can also do v dot x is equal to 10 here, and that way my answer will hopefully be 10. That's how we can change it. I can also create a pointer. I can say p is ampersand of v, and then I can do p dot x, and that would also give me 10. Sorry, 1, because I removed the 10. That's basically our structs. Let's talk about arrays next. The most easy, well-known, most used kind of a data structure. Just like in other languages, we can use an array. How do we define it? We say var, just like while defining any other variable, we say a, and then the type. For that we use square brackets, then we write the size of the array, and then we can just write the type of each element within the array. What do we do next? Let's say a0 at index 0 would be 2. Then I can do a at index 1 would be equal to 5. And then I can print a. Let's see what we get. 2 comma 5, exactly what the array is. But the thing is that array can only be having a static size. It cannot be resized or anything, because the size is basically the part of the type. One another thing we can also do a equal to, I can use the type here and write it like this, and then in curly brackets I can do 5 comma 6. Remove all this, why not, 5 comma 6. That's exactly what it is. The workaround that Go provides for having static size and not dynamic is it introduces slices. So let's make it like 5, and say 1, 2, 7. Then we can define a slice as S. We say A, and then we provide a lower bound, say 2, and an upper bound 4, and we can print the same way we are printing A. Let's print S. Let's see what we get. So S here is a slice. It gives me 1 and 2, which are basically the element at index 2 to the element at index 4. So if I want to print 7 as well, I can do 2 to 5. So it will be, if I'm doing 2 to 5, it will print 2, 3 and 4. If I do nothing here, I will get from the beginning to the end. I can also define S in a way that I can do this, and then I can say int and write whatever I want to write. Say 1, 2, 4. I missed the commas, guys. Don't do that. And we run and we get that. Let's go back to how we were using slices before. Now, what other thing we can get for slices is basically the length of the style, which is like slice, which is like what is the number of elements in a slice, and if I run it, I should get 2, right? Because 1 and 2 are what it is in my slice. But what I also have is a capacity of a slice, which will be from the starting of the lower bound, that is from 1, how many elements there are in the underlying array. So slice is not creating something new, it is just taking a slice from the underlying array. And that is why if I do s dot s at index 0, and if I make it 100, and then I print say a of 2, what do you think I would get? We get 100. So manipulating the slice would in fact affect the array. Now let's talk about slice literal, and how that works is simply we can remove the number from here and a would become a slice and run it. We get the exact same thing. There is another way to declare or define slices is with make. You use make, and then as an input you say first the type, that is int, and then you can tell what length you want. And if I try to run this, I get a slice with the null values that are zeros of length 5. So if I do say 2 comma 5, then 2 will become the length and 5 would become the capacity. And here we have it. And here it is. We got zeros and the size is 2 because the length was 2 and the capacity is 5, and we can't see it here. So let's do one thing. Let's go back to how this was and say int, and let's say it has 3 comma 5. Now I have two things here, right? But now let's get to the best part of using slices. We can use what is called the append function. I can create a new slice and define it here as append, and in brackets I will give a, the original slice, and then I will add whatever I want to add, say 2, 4 and 7. And let's try running it. Says as declared but not used because we also want to print s and see exactly what we are gonna get. Let's say s and run it, and hopefully, yeah, it was appended. And this is how this becomes very similar to what we use as vectors in C++. Now arrays with constant size are no more a problem because we have slices. So in this video, we learned about pointers, slices, and structs. See you in the third video. Bye. Oh, and don't forget to like, comment, share, and subscribe.